For part one, we're going to talk about frequency tables and graphs for one categorical variable. Let's think about John Jacob Astor IV. He was a prominent, wealthy Harvard man. So he graduated from Harvard University. He was born in the 1860s. He was also a science fiction novelist. He was an inventor, and he was a lieutenant colonel. And he made a fortune in real estate. In fact, he built the Waldorf Astoria Hotel, and we have a picture of him right here. At one point in his life, he was worth around $1.7 billion. Now, the thing is that in 1912, he and his wife boarded the Titanic. And he was an incredibly wealthy, white, able-bodied adult male, so he was fairly fit. The question I want to pose, suppose you're a historian, and ask yourself, did this man survive the Titanic? And so let's collect the following data. This is real data on the Titanic. And so you can see we have these cases, and the cases are passengers of the Titanic. These are the first several rows. And then we have several variables. These are the characteristics of the passengers. Each column, as we talked about, is a different variable. And you can see that we have this variable for whether or not the person survived, so it's yes or no. We have a variable for whether the respondent is male or female. These are both categorical variables. And then we have this variable for passenger class, whether you were in the lower, middle, or upper class. When you purchased a ticket on the Titanic, you were put into different classes based on your fare and the accommodations that you received. And then we also have this variable for the passenger's full name. So we can actually identify in our data set where John Jacob Astor IV is located, and we can actually see, did he survive the Titanic? Before we do that, I want to keep in mind what categorical variables really are. They are variables that have values with different categories or qualities. Sometimes they're called factors, and the different categories are called levels. So we've went through some of these examples before, but it's like gender of respondent, approval or disapproval of a social policy, whether or not you're a regular smoker. So in our data set, all the variables are categorical. Now I've highlighted here John Jacob Astor IV. And if you look through that row identifies the data, the observations on him. And you can see that he, in fact, did not survive the Titanic. Now this raises some questions. You might ask, he was an upper class man, but he didn't survive the Titanic. What percentage of passengers overall didn't survive? And what proportion of passengers were in the upper class, you might ask. And you might also ask how many women were on the Titanic as well. It's these kinds of questions where when you look at particular rows of a data set that can really prompt investigation of various ideas. So to answer these kinds of questions, we will want to create tables and graphs for a single categorical variable. One way to really create a table of counts is through frequency tables. A frequency table is just that. You take a categorical variable and you just calculate the counts of observations for each category. Frequency is just a fancy word for counts. So if you ever hear the word frequency, think counts. You're just counting up how many in each category in terms of observations. So right now I want us to focus on how many people survived the Titanic and how many did not. Meaning, if you put John Jacob Astor in the context of the data, was he unusual or was this typical of him surviving? Well, the easiest way to do this is just to create a table of counts. This is a table of counts right here. So we have these two categories of this variable survived. Survived is the name of the variable. And you can see we have no and yes. So we have 618 people who did not survive and 427 people who did survive. And then we have that total. So we have these counts, and then we have these counts of observations for all categories. So you can see that the total size of the data set, the number of observations is 1,045. Besides a table of counts, you can also create what's called a relative frequency table. Sometimes a relative frequency is more useful. So a relative frequency is simply a proportion or percentage of each category. So to calculate the proportion, you just divide the counts by the total number of cases. And then that will give you the proportion, but usually we want to multiply by 100 because often people like to express proportions as percentages. So we call this a relative frequency table, and it's simply a table that gives the categories of a categorical variable, and it gives the proportions or percentages of observations for each category. So here we have our Titanic data on who survived, and on one table we have just the counts. So we have 618 people did not survive, 427 people did survive. And then we have a table of proportions, and we simply calculated that by taking the counts and dividing by the total size of the data set. And then, so you can see for the no category, we have 618 observations within that category, and the total number of observations is 1,045. You divide 618 by 1,045 and you get 0.59. That is the proportion of observations, the proportion of passengers who did not survive the Titanic in our data set. And we could also count this proportion for, calculate this proportion for those in the yes category. So we can see that 427 people survived the Titanic out of a sample size of 1,045. And when you just calculate that fraction, you get 0.41. So we find that about 0.41, that's the proportion of people on the Titanic who did survive. So you can see that John Jacob Astor, he was actually in the majority category. Most people on the Titanic did not survive. And then I'll briefly mention that the total should equal 1. If you're calculating the proportions correctly in a relative frequency table, the total proportion should be 1. So 0.59 and 0.41, they add up to 1. Often, though, we want to express proportions as percentages. So the way you do that is you simply multiply their proportions by 100. So when you multiply 0.59 times 100, you get 59%. Similarly, when you multiply 0.41 times 100, you get 41%. And when you multiply 1 times 100, because the total proportion is just 1, you get 100%. So when you display your data to an audience, they usually like percentages. And so we can conclude that 59% of passengers did not survive the Titanic, and 41% of passengers did survive the Titanic, and the total is 100%. So we have 100% of the passengers. Now, when we look at this relative frequency table for surviving the Titanic, it looks the same. So we have categories, we have the percentage of observations, and we just have the total number of observations. Now, one thing to keep in terms of percentage, the one thing you should keep in mind, however, is that sometimes there'll be a slight rounding error. So if you don't quite get to 100%, it should be pretty close, because sometimes you might round a percentage up or down, so it might be a little bit off.